Let's start with the objectives of this tutorial. Constructive interference example in the real world will allow us to understand what happens in the micro level of physics. When two waves having the same amplitudes interfere with each other, they will have the resultant wave displace in the same medium with the equivalent amplitude as the original ones. Let us see a few constructive interference example and understand the process of the interference. Interference of colors. Single slit diffraction. Young's double slit experiment. Water pool. Speakers. Musical instruments. Interference of colors. Interference in itself is one of the constructive interference example. Let us see how this works. Firstly, what is interference? It is the cojoint of two waves that into contact with each other. Waves can exist in all forms, namely light, sound, and electromagnetic. Waves are made up of two different factors known as the crest and trough. Here, the crest means the top node of the wave, and the trough is the down node of the wave. These top and down nodes of a wave make a big difference when two of such waves go hand in hand with each other. Say when these waves meet, they interfere, meaning internally, they are in phase with one another. When the top nodes of one wave meet another, that is, the crests of two waves meeting one another are termed as constructive interference. Now let us see how this concept works well in terms of colors when considered. Bubble colors are said to be one of the constructive interference examples. There are different colors that come under constructive interference, namely yellow and magenta, where their crests meet another crest and form a wave pattern. Let me also tell you that diffraction is the after effect of the interference phenomena, where the colors generally are deflected at various different angles so finally form a final image. They interfere with each other, so we get a new pattern of waves, sometimes different colors too. Single slit diffraction. Well, one can ask what single slit diffraction has to do with constructive interference example. Actually, it does, if not in the process then definitely in the end product. The single slit experiment is to show how light waves bend around the corner of any target surface, and how well it forms a resultant wave pattern in the same medium, or rather a different one. When we allow the light to enter a slit of the dimension that corresponds to the wavelength of the light been allowed to pass through, now when a ray of light passes through the slit, the light undergoes diffraction and appears as a new type of wavelet. Now how does this become a constructive interference example? The resultant wave will depict whether the wave has been constructive or destructive in nature. The angle at which the light has been displaced in a new position will actually tell about the type of interference. The wave after hitting the target will be allowed to propagate in a specific direction so that the wavefront is formed accordingly. The waves coming out of the slit will interfere with each other in no time. If the wave increases in a particular way, then we need to know that it is a constructive interference so that we get to see a beam of light in the process. Young's double slit experiment. The experiment is more or less connected to the single slit experiment. There it was just a single slit, but in this experiment, we see double openings for the light waves to propagate. The experiment also deals with bringing out the true nature of light, whether it is a particle or a wave. Indeed, it seems to be a wave since it gives a beam in the end result. So it can also be under the category of constructive interference examples where the resultant wave adds up with each other, creating large waves altogether. Their amplitude is the same since the top and down nodes meet each other. Depending upon the type of wave pattern is made when the light wave hits the slits, we decide whether the interference is constructive or destructive. So the angle at which the light wave hits the slit makes a significant impact on the resultant pattern of the wave. The angle at which the light wave hit the target is supposedly taken into account. The reason is when it comes out as a wavefront in which the angle and the number of waves present will decide the type of interference. Water pool. The water pool is one of the best ways to understand the interference pattern, and also it is an easy constructive interference example. So this is considered as an experiment in some instances to understand the interference concept better. For example, consider a person standing inside the pool and striking both hands back and forth. So it will definitely make wave patterns. So when the hands go front and back, the troughs, as in the waves, will cancel out inside. The canceling is termed to be destructive interference. And when the waves keep on adding up each other, then it is constructive interference. The reason is, as mentioned earlier, the nodes of both top and bottom will meet each other, and it will result in the wave pattern having amplitude with a more significant value. The interference made by the wave will have a circular pattern, and they are regarded to be the wavefront, meaning, and the secondary wavelets that comes from the primary waves that mix with each other. Here we see the constructive interference, since the wave in the water pool is added with each other when the water is stroked by hand back and forth. The crest and crest of two waves basically meet at their node points. Speakers. Speakers are an excellent constructive interference example, as they will ensure the sound waves have been heard by the listener when put out loud in a vast hall. Basically, when there are two speakers kept in a hall, and when they both are played together, then they are said to have a constructive interference pattern. The process goes like this: beginning, the sound coming from both the speakers must be of the same amplitude. The reason for the amplitude to be the same is that only then the sound is heard in the same measure. The crests of both the waves must be in such a way that they are equal and meet each other at the exact location. When we consider the sound waves to have the same amplitude, then the waves have their respective nodes in a point where the tops and bottoms meet at the same point and are in phase. The frequency of the sound is also the same when it is connected to one single source, so there is not much loss of energy in such cases. There are also possibilities for destructive interference when the waves do meet, but end up canceling out each other. That is when the crest of one wave is the bottom part of a wave meets the crest that is the top part of a wave, meeting one another at the same point. Hence, when the sound comes out of both, the speakers appear to be the same simply because they have the same amplitude, and even when the wavelength and such factors affect the sound waves. Musical instruments. Musical instruments are a great way to explain the constructive interference example. They have sound waves that interfere with each other and give a result in the form of constructive or destructive. Mainly string instruments contribute mainly to constructive interference. Let's take guitar as an example for this concept. When we tune guitars in such a way that while it is played, we can hear a neat, pleasant tune, and the reason is that constructive interference has occurred in the process of tuning. The reason why mostly the strings instruments are being tuned is that when they are playing, we need to hear the sound, which is in phase and is cordial. The sound waves that resulting out of the played instrument arrange themselves in a pattern where there is no disturbance in the way it has been delivered. The wave's presence increases as it is played because they add up each other, and the amplitude is in such a way that it is more significant than the individual amplitude of the wave. So the crests of the wave's present will undoubtedly team up at one point and the same, also the troughs too. In this way, we can hear a piece of better music, and less amount of noise will be coming out of the instruments. And this is the main reason why the string instruments are always tuned before they are played. Let us see how there are side effects present in such cases. There is something called the beat frequency. Sound is made up of several waves together, which has different frequencies, and when the entire wave meet each other, they either add up or cancel out. So we formally find a constructive interference pattern here. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.